So I'm going to start off with the analogy that how do you know what to write down? Think about if you need to show someone your paper that doesn't speak your language and the only thing they can see is your work. Would they be able to follow it and understand it? So you're writing it down not for you, but for somebody else to look at it and say, yes, I get it. Or think about if you're a lawyer and you're going to prove somebody's innocent. You can't just go up and say to the jury and the judge, say, client's innocent. And ask you, well, why? You say, because I'm great. Same thing in your math. You cannot just say, well, the answer's 5. How do you know? I just know. I'm great. Okay? That's great, but what do you think the judge's going to say or the jury's going to think of the lawyer who says, I don't have to prove anything to you? I'm not going to really believe anything you say because you got no proof. You might be right. Your client might be innocent, but if you don't do the right steps for someone like the jury that knows nothing about law to go through it so they can understand it, they might put your innocent client in jail because you didn't prove yourself. Same thing here. It's not about what you know, it's about what you can prove. And that's what showing all the work is about. Not for you, but for me and anybody else that needs help, they'll understand it. Okay, so keep that in mind. It's not all about you. Doesn't matter if you can do it in your head, that's great, but you gotta prove it. So here we go. Step 1, let's just plug everything in, and when you substitute things in, use parentheses. Doesn't really make a difference on number 1. When you get to number 5, maybe it does. Okay, but they're not too bad. So use parentheses, plugging things in. And we're going to put equal signs each step. And we're going to try to line those up vertically so you can actually follow, see what's going on. If there's only one number left in the parentheses, you don't need a parenthesis any longer. So since I plug in -5, don't really need that afterwards. -5 minus 6, owe $5. You owe $6 more. How much do you owe? You owe 11. Right? And of course, when you multiply, 2 negatives equal positive. You'll see me use a positive sign only when the 2 negatives canceled out and made a positive. Otherwise, I just put 55. So if that said 5 times 11, I just put 55. You don't have to put the positive, but it's just for you to know, like, well, how did you get that? Positive sign means I use 2 negatives. And then box your answer. So at the end, you have to do your closing case, closing arguments. And you have to say, this is what I'm going with. I outlined everything. This is my answer. Put it in the hands of the jury. Then they decide if they agree with it or not. The box on the answer is kind of saying, this is what I want you to look at. This is what I say is the answer. So on a quiz or a test, if you have a bunch of work, you tried it 5 times, circle the one you actually want graded. I'm not going to look at 5 of them, decide which one is the right one for you. You have to pick the one that let me know. Okay? But nothing more than that. If there's only one number involved, like for number 3, you don't really need about the parentheses. You know, you can just do this, do this. There's a negative x right here, so it might be a good idea to do negative with parentheses. By the way, you can use a calculator for anything in this class. Most of you already have a scientific calculator, so homework, tests, quizzes, final, you can use a calculator. If you're not a friend of the fractions, get a calculator that does fractions, and you don't have to worry about missing any algebra problem because of arithmetic. Okay? Can't be on your phone, honestly, if you're taking a quiz or a test. So if your homework, doesn't really matter, but quiz or test, got to have your own. If you're adding a negative, is adding something negative a good or bad thing?
Bad, probably.
Probably bad. Adding a negative thing is bad. That's negative. Same thing here. So negative and a positive and negative is a negative. If you're adding a -6, that's the same as subtracting 6. Sorry, mine's a little rough here. -4 plus 4, which is 0. -6 minus 6 is -12, right? Owe $6, owe $6 more, now you owe $12. And please, if you see a mistake, let me know. I've been known to, while I'm walking around talking, looking at people's paper, sometimes I miss one little thing and I get a wrong answer. Just let me know. We can go back and fix it. So I'll show you a couple things. Most importantly, I'm going to make mistakes. It's not like I do all this stuff all the time. Therefore, it's 100% all the time. So not too bad. I'll let you kind of finish those up. But here's where we really kind of get into the important part. Is your answer correct? So if you plug in this answer, is it a solution or not a solution? So some will be true, some will be false. So let's pretend you already solved it and you got this answer. You're checking. This is checking to see if it's actually right or not. So it's really not an equal sign here. It's is it equal? Because if they're equal, right, that means it's a solution. Oh, solution. That means it's a solution. And I say equal, I mean the right and left hand side. So if the left is equal to the right, it's a solution. And then if the left is not equal to the right, then it's not a solution. No solution. Or not a solution. If it's not a solution, that means you redo it. This is where your grade goes from a C to an A on a quiz or a test, because anything you didn't know, you redid. Anything you got wrong, you redid it. So A, you got it right, or B, you ran out of time, the bell rang or whatever, and you did everything you could. If, of course, it is a solution, that means you're done. So this is the most important part about everything we're doing today. If it's not a solution, you have to redo it. Not these actual problems, because we're just checking for this. But from here on out, anytime you can get this not equal to each other, you're not done with that problem. Keep redoing it. So is 19 over 4 equal to negative 7 over 4 plus negative 3? That's the question. Again, try to line these things up vertically so it's easy to follow. So I'm just going to have right below 19, negative 19 over 4, equal sign. And then if you have a calculator, you can just punch this in, negative 7 over 4 plus negative 3, and you can know that equals 19 over 4. You might have to go and hit the buttons. It might give it to you as a mixed number, not an improper fraction like it is here. But you could do it. If not, you just have to do the old-fashioned way, which takes, a matter of seconds anyway. So we know we need a common denominator. This is really a division problem backwards. So what divided by 4 equals 3? That's the question. 5 minutes. Oh. Okay. Negative 3 is the same as negative 12 divided by 4. We just took out negative 3 and put in 12 divided by 4 in its place. Now it's the same match. And then negative 7 minus 12 is negative 19. So in this case, yes. Negative 3 is a solution. And the last step is to actually show the same thing on both sides. This is called the identity. Or I think if you guys remember from geometry, that's reflexive. You have the same exact thing on both sides. So we could say here that negative 3 is a solution. And this is the answer. Solution, not a solution. Yes? No decimals needed. As long as you have the same thing on both sides, it's fine. Yeah, decimals are good sometimes. They work sometimes, like dividing by 4, decimals work very well. It's just when you start dividing by 3s and dividing by 6s and 9s and multiples of these come out to repeating decimals, and you can't really, it doesn't really work that well. So we want to stay away from it as much as possible. It'll get us in trouble later. Okay, not too bad. So that's adding, subtracting fractions. Again, 799, if you're not liking this, get something, you can just type it in. It'll tell you 19 over 4, and then you can just skip this whole middle step and just write 19 over 4 equals 19 over 4, and you're done. It'll be a good investment that'll go a long way. When you're multiplying, just Remember, it's top times top, bottom times bottom. Use a parentheses when you're plugging things in. Anything I say that you don't recognize, you're not sure about, that's what you take notes about. Your notes should not match anybody else's, really. I know some people think notes is copying the board. That's not really taking notes. Notes is something for you to look at later because it's new to you, or you've forgotten. So like this, if you're not sure how to multiply this, I say top times top, bottom times bottom, you want to make a little note. And nobody's going to remind you. Nobody's going to come over and check to make sure you're doing this. You just have to do it on your own because you know that you'll need this later. You often forget how to do that. And you can abbreviate, so it doesn't take that long to write out. And that way, when you guys go to do your homework, the next problem right here, how do you do that? Your notes are right here. Oh, I do top times top, bottom times bottom. Okay. You don't have to go looking for it and wonder. It's already right there. So take the notes right there. But if you already knew this, of course, you don't write it down. Whatever you need for later. Directions to yourself. Okay, so it's 8 over 9 equal 2/3 times 6 over 3. 2 times 6 times top, bottom times bottom. And these have the same denominator, so since the tops aren't the same, then no. That means 6 over 3, which is really 6 divided by 3, which is 2. That's not a solution. So if this is an answer you got on the problem, this is when you go back to the original problem and try again. And you keep going, then check it to see if that answer is right. You keep on checking until you run out of time or you get the right answer. And a second. Yes. Just know that tomorrow that I expect all of these to be done completely in the similar way that I've shown you. Do not abbreviate it, shorten it. Try to make less writing for yourself because you can do it in your head. The whole premise today is regardless if you can do it quickly or not, you're still going to take the time to prove your case. You can be the smartest lawyer in the world, and you can have the not smartest jury in the world. That smart lawyer can't just talk and say all these smart things that the jury's not going to understand. They still have to slow down and spell everything out step by step to prove it. Okay, so 6 is the solution. So you guys did a basic 2-step equations a long time ago. And we can check those pretty quickly, like so. And they might get bigger. That's okay. It might take longer. Now, by taking longer, how long do you think it would take to solve 15 or check an answer for number 15? It's bigger. Now, average is about 20 seconds. So before you look at that, sometimes we're our worst enemies when it comes to things. We think it's so hard, and we spend a minute or 2 minutes like, I don't want to check it, I don't want to check it. And then you finally do it, it's like, oh, that took 20 seconds. So if you just do it and don't worry about how long it'll take and just get it done quickly, you'll find out that it really doesn't take that long. That's me thinking one thing and reality, something else is true. Kind of like when you take like a straw and you put it in water and it looks like it's bending. You know, a straight straw and it looks like it's bending a different direction when really it's just a straight straw. You think it's one thing because you see one thing, but really in reality it's something different. And don't skip any steps, don't hurry up, don't try to do it fast, and you'll be okay. That's what it's all about. And feel free to use a calculator when needed. You don't have to use it all the time, but if you're not sure at some point, why not? A few things. You notice how I'm lining up the equal signs? I'm trying to line up numbers as much as possible that don't change, like the -4s here. Stay lined up so it's Again, not for you, but for me or anyone else trying to look at your paper, they're going to go and look at it and say, okay, that makes sense. That's not changing. You know, oh, that's where you got the 16. That's where you got the negative 12. Very easy to follow. Make it clear as possible. Again, that's negative times negative, so that's positive 48, positive 48. So therefore, negative 4 is a solution. And you guys already know, since there's the exponent's only to the first power, there's only going to be at most one solution. Could be a no solution, but most one solution. All these will be, you're not going to have any, what do you call those? No solution of all reals. We won't do those yet. Let's go down to here. Little review for graphing linear equations, straight lines. That's how we did this, y equals mx plus b and all that stuff. So instead of two things, you have an x and a y. So you have to check both. Not too bad, right? 5 minus y is negative 7. Does that equal 11? Negative and a negative. Positive? You ever wonder why a negative and a negative are positive in mathematics? It's actually the same thing in every single language. And I kind of hinted on before. If you take away, get rid of something that's negative. Now think of something that's not good for you or whatever, not good to do. You get rid of it. Is that a good or bad thing? Good thing. That's how you actually think already. So that's why it's that way in math. The math and the symbols came after the idea of that's how we already think and operate. So if you're not sure about those signs, just think about something more realistic. And you'll see that it makes sense both ways. So 12 equal 11? No. So therefore, not a solution. Now, you do want to write out not a solution as opposed to no solution, because this does have solutions. This is just not one of them. So this no solution is not the same thing. No solution is it's impossible to find an answer. And these, when you have two variables, they have infinite number of answers. There's a bunch of those that will work. There's a bunch of numbers that will subtract and equal 11, not just one of them. We're just checking only one. Have to plug it in. Right. So my y is, remember, it's the second number. So 3 minus 1 equal fourth time 4 plus 4. And try it on your own if you think that's the hang of it. Don't just write down what you see and say I'm done with it. But try it on your own and check your own. You want to walk out of here knowing that you're good, not hoping later it'll be fun. So if you ever had that feeling that you left your math class especially, and then you sat down to do your homework later, and you're like, I have no clue how to do this, probably because you're copying the board the whole time. You're not learning anything. You're just copying the board. Try to do it on your own. Check to see if you got it. If not, ask me, raise your hand, talk to someone quietly next to you, figure it out. But you want to already make mistakes before you leave here, and then you'll know for sure that you got it. Okay. There we go. So 3 minus that. A fourth of 8 is the same thing as 8 divided by 4. These are identical, by the way. Taking half of something, dividing something by 2, same thing, right? Half of 10, 10 divided by 2. So same thing here. So we got 2 equals 2. So solution. That means 4, 4,3 is a solution. One of infinite number of solutions. Good. I think lastly we have quadratics. If I'm not mistaken. Oh, systems. All right, systems both have to be true. Same idea. Both have to be equal. or true. So if you check one, that's great. Don't say it's a solution yet. Have to check both. You might remember graphically, this is where two lines intersect. So if it's true for this one, that means it's on this line. And if it's true for this one, that means it's on this line and it's where they intersect. So it could be true for one, but false for the other. So you got to check both. So just more of the same that we just did. So 1, 5. 4 times 1. Now, if this is the part you're like, oh, this is taking forever, that means you haven't really checked a lot of answers in the past. Let go of the feeling that you're having right now and use more rational thought. Like, it doesn't matter if it feels like it's long. Forget that. Quit thinking about what I feel about it and how long I think it takes and how hard it is. Right? Flashlight warning? Good job. And just focus on the results. Doesn't matter how I feel about it. Is it going to be a good thing for me later or not if I do it? It has nothing to do about how you feel. Sometimes we get caught up on that and it slows us down because our feelings about things usually are not correct. First impressions not always correct. So it can get in the way. So we got 4 plus 5 plus 9. So the first one is true. That's good. Check the second. -5 plus 10. Is that 5? 10 minus 5. Sure enough. So therefore, 1, 5 is the solution. And we know that these are both straight lines. There's no exponents, not to the second power or anything. So these are straight lines which can only have at most one solution if they intersect. Sometimes there's infinite solutions, but I'm not going to worry about those right now. So do check both. If either is false, the answer is no. All right, and lastly, I think we have the quadratics. Yes. So when they're written in the braces, not parentheses, that means both of these are m, as opposed to what we just did in parentheses. One was x, the other was y. They're different variables. When they're the braces, it's the same variable. There's only one variable. Okay? So there is a difference between using parentheses and braces. It's how many variables you have. So we're going to check both because, you know, since it's quadratic, it could have 2 answers. Quadratics have up to 2 answers. And if you recall, an answer for a quadratic is where it crosses the x-axis. Here and here. So it could have 2 answers. It could have no answers. Doesn't cross the x-axis at all. And it could have one answer if it crosses that one point. So that's why we write it differently for something that has to the second power, because this is the number of solutions that are possible. If you're ever wondering how many answers could there be, the highest exponent, that's how many possible answers. So you want to check both. And unlike before where we did the system, this you can have one's an answer, one's not. You don't have to have them both true. So we can do 3 times 3 squared minus 9. Does that equal 6 times 3? Now, the way I just wrote this right here, please use this format. Use the dump. It'll save you so much headache later on because there's a lot of mistakes made in order of operations at this point. So if you just separate the 3 from the m squared and put it like 3 times, it'll make your life a lot easier later on. And so we'll check that and we'll do the same thing here. 3 times -1 squared minus 9. Does that equal? Again, this is very deliberate because of the negative. I used parentheses. Over here, I didn't. That's very actually makes a difference. How you write it down changes things. Order of operations, do those exponents first. So I'm going to do 3 times 9 minus 9. Does that equal 18? 27 minus 9? Yeah, that's 18. 27 minus 9 is 18. So for sure, 3 is a solution. Negative 1 times negative 1 is positive 1. 3 times 1, 3. And then 3 minus 9. So both of those are solutions. So if we graphed it, it probably looks something like this. It'd be crossing at 2 different spots. One at negative 1 and one at positive 3. And if one's false, that means only one of them is solution. Again, not like above where it could be one or the other. But this is where we have the most common mistakes is with quadratics. So definitely separate it where the square is, and you'll have fewer problems. Okay, that's about it. For me, you guys spend the rest of the time finishing up everything you can. As I mentioned yesterday, if you're here, you'll have very little homework if you do everything you're supposed to while you're here. So with the free time you have, if you go right through it, you're checking your answer with someone next to you and making sure it's right, you have little homework. And it's almost all the way done. If you can, take it easy, and you're like, I'm tired, I'm hungry, just know you'll have more homework every night. It's a personal choice. It's up to you. Have good days and bad days, but know it's in your hands. And please sit and work with someone that's going to help you. Not going to hurt you, not going to slow you down, not going to be talking in your ear and make you learn less and know less every single day for 180 days until you come to the end and realize, I don't know quite as much as I should. Pick and choose who you want to work with, and they have to help you, not hurt you or slow you down. Okay? Other than that, have a good day.